Hello students, today we will start new series on machine learning. Okay, so in this series we will make two playlists. One is for theory session and then we will do practical session. Okay, so let's start. So what is machine learning? The first question is what is machine learning? 1 minute, let me see. Can we have what is machine learning? Okay. So machine learning is the scientific study of algorithms and statistical models that computer system uses to perform a specific task without using explicit instructions. Okay. So what is machine learning? Scientific study of algorithms and statistical models that computer system uses to perform a specific task without using explicit instruction. Okay. So what we feed to machine learning algorithm is data, or you can say experience. Okay, so we will feed data into machine learning algorithm. So algorithm learns pattern from data. So what algorithm do? It will learn patterns from data and will tell us. Okay, now the question is what is the difference between traditional programming and machine learning? Okay, so there is one basic difference between traditional programming and machine learning. So for traditional programming, what we are doing, we are providing data and program to the computer, okay, and then our computer will give output. But in machine learning, what we are doing, we are providing data and output to the computer, and computer will prepare program for this, okay. Now there is another term, that is ETP, which means experience. E for experience, T for task, and P for performance measurement. Okay, so what is experience? So experience is our data. Okay, and what is task? And what is task, guys? Basically whatever we want to predict. Okay, like predicting the stock price, issue, we should issue loan or not. So like this we need to do. Okay, so issue loan or not, detecting cancer cells, etc. Okay, now now there come one more question. What is the difference between deep learning, machine learning, and artificial intelligence? Okay, so machine learning, we already see that it is the scientific study of algorithm and statistical models that computer system uses to perform a specific task. Okay, that is machine learning. Now what is artificial intelligence, guys? Machine performing tasks based on a set of rules to solve problems. Okay, machine performing tasks based on a set of rules to solve problems. Such an intelligent behavior is termed as machine artificial intelligence. Okay, so what is there? So our machine mm, is performing tasks based on a set of rules to solve problems. Okay, so we define a set of rules and then our machine is performing tasks on the basis of those sets of rules. So such an intelligent behavior is termed as artificial intelligence. Okay, so what basically we are doing, incorporating human behavior to machines. Okay, this thing you don't need to study. Here what I am doing, I am highlighting what you need to concentrate, else you can leave. Okay, now what is deep learning? Okay, so deep learning, deep learning, evolution of machine learning inspired by the information processing patterns found in the human brain. Okay, so deep learning is the evolution of machine learning inspired by the information processing patterns, okay, found in the human brains, that is neurons. Okay, so this is the thing. Now what is the application of machine learning? There is many applications like text and speech recognition, okay, email spam filtering, okay, image recognition, then virtual personal assistant, okay, traffic prediction, recommendation engine, and then medical diagnosis and online fraud detection. So these are the like we can recognize text and speech, email spam filtering, image recognition, virtual personal assistant, traffic prediction, recommendation engine, mechanical diagnosis, medical diagnosis, online fraud detection. Okay. So now what are the types of machine learning algorithm? Machine learning algorithm is basically divided into three types. First one is unsupervised learning. Okay. Then we have supervised learning, and in the end we have reinforcement learning. Okay, so unsupervised learning can further be divided into clustering and dimensionality reduction. Okay, and supervised learning can be divided into regression and classification. Okay, reinforcement is another thing in which we learn by doing. Okay, now let's discuss what is supervised learning. Okay, we have a well defined target variable to go after. Okay, known as label data. Okay, so that is supervised learning. Now, what is unsupervised learning? No target or outcome variable is present. Okay, so that is unsupervised learning. The algorithm will try to find pattern in the data. Okay, and tell us that is unsupervised. Okay, and now what is reinforcement learning, guys? Allows the machine to or software agent to learn its behavior based on the feedback from the environment. Okay, allows the machine or software agent to learn its behavior based on the feedback from the environment. Okay, so this is reinforcement learning. Okay, so this is the life cycle of machine learning projects. First we have business approach, then data preparation, then exploratory data analysis, after that feature selection, then modeling, after that business interpretation. Okay, so now come the question, what is regression? Guys, regression is the predictive modeling technique which investigates the relationship between a dependent and independent variables. Okay, so regression is the predictive modeling technique which investigates the relationship between a dependent and independent variable. That what is the relationship between independent and dependent variable. Okay, so now come the linear regression. So what is linear regression? It signifies the linear relationship between dependent variable and one or more independent variable. Okay, guys. So this is the linear relationship. Now come the correlation. So what is correlation? It defines the association between two random variables. So correlation defines the association between two random variables. Okay. uh, Value of correlation maybe between -1 to 1. Okay, so for example, like we have here x and y. Okay, so if it is like this, okay, so this is like positive correlation. Okay, and if we have like this, so this will be negative correlation. Okay, guys, so this is the thing. Or like if we have third one also, so this is zero correlation. Okay, so correlation is between any two variables. So this is the thing. Okay, so types of linear regression. So linear regressions are basically of two types: simple linear regression and multiple linear regression. In simple linear regression, it comprises of linear relationship between exactly one dependent and one independent variable. Okay, so one independent and one dependent variable are there. For example, ice cream sales prediction. Okay, number of units sold with respect to change in temperature. Now comparison between equation of line and equation of regression line. So guys, equation of line is represented as y equal to c plus mx, and equation of regression line is represented as fx equal to beta naught plus beta 1 x. Okay, here c is the intercept and m is the slope. Here beta naught is the intercept and beta 1 is the slope. Okay, on comparison we can find that y equal to fx, c intercept equal to beta naught, and slope m is equal to beta 1. Okay, so this thing also we can get. Now graphical explanation, fx equal to beta naught plus beta 1 x. Okay, so what we have this line. Okay, now we have this intercept. Okay, means at what point it is cutting the y-axis. Then we have this theta. So tan theta will tell us the slope of the line. Okay, so this will tell us the slope of the line. Now guys, there is one more term, that is cross validation. What is cross validation guys? We divide our data into train and test. Okay, so this is known as train and test split, and also known as cross validation. We do this to check that our model is prepared correctly or not. Okay, because we don't have future data right now. Okay, but we by doing train test split, test data will work as a proxy of our future data. Okay, so we do this train test split. I will explain in details later. Okay, don't worry this term. Okay, so if you right now you are not getting, not an issue, later you will get it. Okay, we must check for dataset which is proxy for tomorrow. Same thing written here, proxy for tomorrow. Objective of creating machine learning uh, model. Okay, what is the objective? So our main objective is predict for data yet unseen. Okay, so we want to predict for data which is yet unseen. Okay, so we have linear regression. So in linear regression, our machine learning, this I already explained, same thing. Okay, so this is, so going from home to office. Okay, what is scatter plot? Okay, now question is, what is scatter plot? Okay, we have two variables x and y. X is our uh, independent variable and y is our dependent, or you can say target variable. Okay, so what we will do, we will so we have like these rows also. Okay, where values are there. Okay, so what we will do, we will draw it on the scatter plot. So every row, okay, for example this row, so for this we have value of x and value of y, so one point will come here. Okay, so this is the scatter plot, means every dot is representing one row of data set. Okay, now one example, going from home to office. So how we can decide that when we should leave from home to office? So this is importance of meeting. Whatever important meeting we have, like with MD, with boss, or with friend, on that basis we can divide. Okay, now what is regression? Regression is return to less developed state. Okay, if you search on Google, you will find meaning of regression, return to less developed stage. Okay, so here price is depend on square footage or pool. Okay, for example, we go like I have one house. Okay, and I need to buy one house, and I go outside and search for some house. So I come at home, someone asks me that have you I have asked me, and I tell that I have seen one house and the price of house is 45 lakhs. Okay, so that person asked me that what is the specification for that house, what is, how much area, how much floors, how much rooms, etc. So I said 45 lakhs. Okay, next day I go outside and search for house, and then I come back, that same thing, and then someone asked me, what is, have you seen anything? So I said I have seen one house and the price is 65 lakhs. So he asked what is the details, so I said 65 lakhs. Okay, so basically in regression we are defining the price of house with the help of some details. Okay, so we are going to less developed state. Maybe there are many other factors which are dependent, on which price may be dependent. Okay, so single variable is lost of information, like we are losing many information. Okay, so this is the thing. So the overall idea of regression is to examine two things. Does a set of prediction variables do a good job in predicting an outcome variable? Okay. And another one is, which variables in particular are significant predictors of the outcome variable? Okay. Which variables in particular are significant predictors of the outcome variable, and in what way they do impact the outcome variable. Okay guys, so this is the thing. Okay. Now we will see one example, that is temperature versus ice cream sale. Okay, so first question is, why we want to construct the regression, guys? Okay, so we want to construct the regression because so that we can plan our production accordingly. Okay, if we come to know that this month ice cream will be sold in this month, so we can our plan our production accordingly. Like if sale will be high, so we need to produce more ice creams. Okay, also maintain our stock. Okay, so how much stock we should maintain, this also we can come to know. Okay, so target variable, what is target variable? Target variable is something which is difficult to measure or very costly. Okay, like sales of ice cream. And explanatory variables, like these are easy and cheap. Okay, so we can easily get these. Okay, so ice cream sales is depend on temperature. Price depend on square footage, pool, or distance from market, on these things. Okay, so what we are doing here, we are hypothesizing. Okay, what we are hypothesizing, that temperature will cause ice cream sale. Okay, so this is the thing which we will do in regression. Okay, we hypothesize things. Okay, so hypothesize y is proportional to x. Okay, my y is explained by x. Okay, so now, mm, is regression and correlation are same or causation? Is regression in regression we are hypothesizing the causation, but in correlation we are not. Okay, so this is the basic difference between correlation and regression. Okay guys, now come our term, that is linear regression. Okay, so let's see, like we have temperature 30 degree, 20 degree, 38 degree, and then we have actual ice cream sales 65, 26, 76,000. Okay, and then we are predicting. Okay, for example, like we have developed one model and we will say that 60, 40, 75 will be our ice cream sales. So now we can calculate error. Okay, so what will be error? Error will be our actual minus predicted. Okay, so error will be our actual minus predicted. Okay, actual minus predicted, so it will give our error. Okay guys, so for example, we have developed one model that ice cream sale will equal to 2 times the change in temperature. Okay, so here we have temperature and here we have ice cream sales. Okay, so we will draw things, and then what we are doing, we will draw linear equation here. Okay, so what we do, we will hypothesize things like ice cream sales is 2 times temperature plus 0, and then ice cream sale equal to 0.2, into temperature square plus 50. Here transformation we need to do on target variable because it should be linear. Okay, so like this we are doing. Okay, so when we call it good, okay, so this hypothesis, like this equation which we are finding, so when we call it good, okay, for this we should make sure that our error should be least. Like here 5 is coming, minus 14 is coming, 0 is coming, so our error, okay, should be minimum. Okay, so which error should be minimum? Like this one or this one. Our overall error, okay, aggregate error should be minimum. Okay, so how we will find? So we will use RMSC value. Okay, we will see this in detail in model evolution techniques, but here also we will see root mean square error. Okay, so what is root mean square error? So root mean square error is actual minus predicted, that is error, and then square, and then we will take mean. Okay, summation of actual minus predicted divided by total number of observations, and then root. Okay, so this will become our root mean square error. Okay guys, so this is the thing. Okay, so this is the thing. So what we are doing with with the help of temperature, we will calculate ice cream sales here, actual, and then we will predict, and then we will calculate error. Okay, so now we will draw this on this. Okay, so our assumption line will come like this. Okay, so here we will see that this is the our error, this will be our error. Okay, so guys, what will happen, like these are the points. Okay, so this is our line. Okay, what will happen if we will draw our line here? Okay, so what will happen, this will become our error, so our error will increase. Okay, so this will be our RMSC aggregate of all these errors. So what we need to do basically, we need to minimize our RMSC error. Okay, so how it will happen? For this we need to find the middle line. Okay, so for example, at the last we are able to come up with this line, that ice cream sale equal to m into temperature plus c. So we are able to find value of m and c. So if we are given with 27 degree, what will be the ice cream sale on 27 degree centigrade, then we can tell. Okay, so this is the thing. Now guys, here our motto is not to get a line of perfect fit. Okay, but to get the line of best fit which has least amount of error. Okay, so here our motto is not to get a line of perfect fit, but to get line of best fit which has least amount of error. Okay, so this is the thing. Okay, so how we will get minimum RMSC? This is we need to calculate for all these. Okay, so for example, y equal to beta naught plus beta 1 x, so we need to calculate our beta naught and beta 1 value for minimum RMSC. So this is the thing. Okay, so if we talk about RMSC value, so here we have 1 by n summation of error ka square by uh, under root. Okay, so here what is error? Y actual minus y predicted. Okay, okay, so here this our number of terms is constant. Okay, under root is constant. Okay, so what is our variable? This error y actual minus y predicted. This is this will be our sum squared error. Okay, Now what is error? Actual minus predicted. So what, y actual and let's suppose y predicted will be beta naught minus beta 1 x. Okay, so here this actual is constant and this value x is also constant. So our main objective should be to get the value of beta naught and beta 1. Okay, so this is the thing. Now guys, then after this, mm, for example, we predict y, that is stock up prediction. Okay, so what should, while predicting y, what should be our target? Okay, our target should be that error should be minimum. Okay, we should have least amount of error. Okay, on, and this what we will this do we this thing we do on what, on historical data. Okay, so here is temperature and leave it. So this is the thing. Okay, so now what, why we are doing this? So that we can do prediction. Okay, prediction on what? Prediction on future data only. Okay, so we need to analyze that our prediction system is working correctly or not. Okay, so for this what we will do, we will use model evaluation technique. Okay, so like we will on historical data we have prepared this equation, that is y equal to beta naught plus beta 1 x. Okay, this is the for prediction for future. Okay, so now we have draw this line, for example for new value of x, for x tomorrow. Okay, we should be able to get the value of y. Okay, so this will be x, this will be y actual, y predicted, and then error. Okay, so this is the thing. So for evaluating our model, what we will do, we will divide our data into two parts, that is train, okay, generally 80%, and then test, that is 20%. So our target is not to reduce this train RMSC. Okay, our target is to uh, reduce this RMSC test, that is future error. Okay, and this process is called cross validation. We are not interested in minimizing the irreducible error. Okay, we are interested in minimizing the future error. Okay, so this is the thing, we are not interested in minimizing the irreducible error, we are interested in minimizing the future error. So for that we do train test split. So now we will discuss about model evaluation matrix. Okay, so what are the method we can use? Okay, first one is RMSC. Okay, root mean squared error. So it is the square root of the mean of the squared error. Okay, so what is RMSC? It is the square root of the mean of the squared error. Okay, so formula is under root 1 by n summation of y actual minus y predicted ka square. Okay, n is used to normalize the RMSC test at the first place. Okay, okay, so if we have data we can do RMSC at the first place. Okay, so this is the thing. Okay, so now what is R squared? It is the proportion of variance explained. Okay, meaning the proportion of variance in the observed data that is explained by the model, means how much variance our model can explain. Okay, no need to see this diagram, this will be very confusing. Okay, so like I explained, it is the proportion of variance explained, meaning the proportion of variance in the observed data that is explained by the model. Okay, r squared value is between generally 0 and 1, and higher is better because it means that more variance is explained by our model. So formula we use for r square is 1 minus unexplained error upon, sorry, 1 minus unexplained variance upon total variance. So if we solve this, so it will come here, total variance minus unexplained will come as explained variance upon total variance. So r squared will be explained variance upon total variance. Okay, so the thing is, we have house price. Okay, so the thing is, we have house price, that is 50 lakhs, 25 lakhs, 35 lakhs and 20 lakhs. Okay, so if we take the average of this all, it will come as 28.5 lakhs. Okay, so this is okay, but why there is so much variation? Okay, so why there is variance, like one house have 50 lakhs price and other one has 20 lakhs. So this is the thing. Okay, so if we draw this line, so this thing, this variation is our unexplained variance and this will be our total variance. Okay guys, so actual is our total variance and error will be our unexplained variance. So this is the thing. So r square is explained variance upon total variance. R square is proportion of variance explained by, means proportion of variance explained. Okay, so what is hyperplane? Hyperplane is the straight entity in multi dimensions. Okay, now we will discuss about linear regression in higher dimensions. Okay, in three-dimensional space, we will define plane equation as y equal to y1 x1 plus y2 x2 plus beta naught. Okay, so if we have only one variable, then it will come here and this will be our target variable, and we can get the equation of line. So it will be in this will be in 1D. If we have two variables like x1 x2 and then y, then we can have x1 x2 and their y. Okay, so here the equation will come in a plane. Okay, if we have more variables like x1 x2 x3 and target variable y, so we have equation in another dimension. Okay, so here y is depend on x1 x2 x3 and all. Okay, so we need to calculate all beta related to those. Okay, so how we will calculate those betas, and those beta will be calculated on the basis of RMSC only. Okay, so now we can say that if we have n explanatory variable and one target variable, then we need to draw n dimensional hyperplane. Okay guys, now what is hyperdimensions? In higher dimension we use hyperplane to predict output. Okay, so what is hyperdimensions? In higher dimensions we use hyperplane to predict output. Okay, equation of hyperplane. So equation of hyperplane is y is equal to beta naught plus beta 1 x1 plus beta 2 x2, like this. Okay, so this is the equation of hyperplane. Also we have some of the error, some undefined thing associated with that, that is random error. Okay, so what coefficient basically do? Coefficient help us understand the importance of particular variable in the model. Okay, like uh, what will happen? Okay, now like y equal to beta naught plus beta 1 x1 plus beta 2 x2. Okay, so now for example value of beta 1 will come as 0.2 and value of beta 2 will come as 0.7. Okay, so it means that x2 is more important than x1. Okay, so coefficient help us understand the importance of particular variable in the model. Okay, so now let's suppose we have square footage and then age and then price. Okay, one house have area of 800 square feet and it is 2 years old and we have price of 50 lakh. Another house have square foot of 1300 foot and then age it is only 1 year old and price is 85 lakhs. Okay, so if we do regression and predict the output, and then we come to know that p is equal to beta naught plus beta 1 x1 plus beta 2 x2. Here x1 is age, okay, and x2 is square footage. Okay, so if you see that our x2 will be in hundreds. Okay, so it will be in hundreds, and our x1, that is age, it will be in units. Okay, so if we want to comes in lakhs, that is in this digit 50 digit, then we need to multiply with higher value of beta 1, okay, and lower value of beta 2, okay, because it is unit, so we need to multiply with a 5 digit beta 1 value, and it is in already in 100, so 3 digit beta 2 value. So what it signifies means what it signifies, guys, that uh, co as we already see that coefficient help us under importance of particular variable. So it tell that this x1 is more important that than x2, but it is not the case. Just because x1 is in unit, so that's why beta 2 value is high, beta 1 value is high. So for this, we need like different explanatory variables can be in different scales. So we need to bring them in single scale. Okay. So this thing is called as scaling. Okay. Scaling we should do after train test split. Okay. So what we'll do? We will do scaling. For this, we have different types of scaling. We will discuss that also in detail. So we have min max scaling. Then we have standard scaling, also known as Z score. So these are the things. Okay, so this is the thing. So we will calculation of multiplication factor for all explanatory variables. Okay, so then in min max scaling, what we will do, we will consider minimum value as 0 and maximum value as 1, and then we transform all those according to that. Okay, so this is the thing. Okay, if we will do scaling, after that it will come in like this value. Okay, price will remain same and these two will be changed. So um, this is the thing. Okay, now come the another part, that is assumptions of our linear regression. Okay, so there are few assumptions which we need to take care before applying our linear regression model. Okay, so what are those assumptions? There should be linear relationship between dependent variable and independent variable. Okay, so we should keep in mind that there should be linear relationship. For example, here we have price versus quantity. Okay, so as quantity is less, so price will be less. Okay, as quantity keep on increasing and price, so price will also start as quantity will decrease, so price will increase. So quantity and price are inversely proportional to each other. So here what we have to do, first we need to transform our explanatory variable. Okay, like price, we will what we will do, we will draw graph between 1 upon price versus quantity. Okay, so this is the thing. Okay, so if if we drawing like we are driving the car, then we are facing some force in the opposite direction, that is drag force, and that is proportional to v velocity ka square, speed ka square. Okay, similarly we need to transfer 1 upon x, x square, x cube, log x, sin x. So these types of transformation we have to do so that we can have a linear relationship between dependent variable and independent variable. Second is target variable should be normally distributed. Okay, so our target variable should be normally distributed, like y is proportional to features. So random error, okay, random error is there, then it should also be normally distributed. Okay, so for this what we will do, we will transform our target variable. We can use log y or square root of y, like this we can do. Okay, and then we need to do reverse transformation also. Okay, now the independent variable should not be correlated. Absence of this phenomena is known as multicollinearity. So it means that independent variable should not be correlated. Okay, so for example, for the we have built up area and super built up area. Okay, so generally super built up area is 1.3 times like built up area. So what will happen if we have like this? So beta naught plus beta 1 build up area into beta 2 super build up area. So what will happen that we can drop any one variable. Okay, if, if multicollinearity is present, it becomes difficult to find out which variable is actually contributing to predict the response variable. Okay, so this is the thing. Okay, now our fourth assumption, the error terms must have constant variance. Okay, जो our error terms must have constant variance. This phenomena is known as homoscedasticity. Okay, so the thing is, the term which we have error, so variance should be like should have constant variance. Okay, so means no variance is remaining. Okay, it should be constant variance. It should not be like this. Okay, means we no more information we can fetch from there. The presence of no heteroscedastic. And we, by the help of statistical terms, we know that the error term must be normally distributed if target variable is normally distributed. Okay, there should be no correlation between residual terms. So this will we will study in time series in details. Absence of this phenomena is known as autocorrelation. Okay, so there should be no correlation between residual terms. Okay, so this is the thing. There there should be no correlation between residual terms. Okay, for example, we have x, we have y. Okay, so this like here it is explained. X, Y, and Y predicted error 1 in this E2, E3. So these no error term should be correlated. So this is the thing. Okay. So logistic regression dot fit. Okay, scaling and all these things, calculation of these multiplication factor. Okay, we will do scaling after train test split also scale data. So we need to scale our future data also, since we have calculated beta 1 and beta 2 on our scale data. So if we are getting any data in future, so we need to do scaling on that data. So this is the theory on linear